Good morning, everyone. Welcome to our session. My name is Ling Li. I work as an AI ML go-to-market specialist at Amazon Web Services. Very excited to be here today with you, and together with my colleague Salman and our customer Alex from Smava, we're happy to share with you the latest innovations of Amazon Cloud Data Warehouse Redshift in the era of generative AI, some of the use cases and some of the new features. Alex will come up to stage and share with you how Smava uses Redshift to boost their business productivity and innovation, and we will end the session with an exciting end-to-end demo done by Salman. You will walk away knowing the latest features and having some inspirations about how those features can bring extra values for your data platform and for your day-to-day business. Generative AI has taken the world by storm since last year. By now, from the innovation speed that we've seen, we know that the true power of GenAI stays way beyond just a chatbot or a search engine. So it will transform how organizations and companies operate every day. So how can you be successful in this journey? While many people are looking for the best models out there with the largest data set trained, we think the true differentiator is actually your data. The data that knows all about your company, your business model, your customer. At Amazon, we provide a list of services and tools for you to be successful in this journey. If you would like to build your own foundational models, we want to provide you the best purpose-built infrastructure, such as the best chips, GPUs, best clusters, network. To data foundation, some of the databases, analytics services, machine learning tools, foundational model as a service, to generative AI-powered applications such as Amazon Q, and you heard of that from the keynote. And today, we are focused on your differentiator. How can we build that solid data foundation to prepare for your GenAI journey? As you can see here, we have a list of different services to help you get those data in. Doesn't matter where it sits in your organization and whatever format it has. We want to bring those data into your data lake or your operational databases or your data warehouses so you can store them, transform them, query, analyze them, and make them ready for your GenAI application. And let's zoom into our data warehouse. Amazon Redshift was first announced in 2013, so it's a bit of 11 years. It was a significant leap from on-prem data warehouses in terms of scalability, flexibility, performance. And we've added many, many new features since then. For example, serverless, data sharing, and zero-ETL. Many customers have been using Amazon Redshift to run their workload and make business decisions day to day. Do you know that NASDAQ scaled from running 30 billion requests to 70 billion requests per day using Redshift? And Samsung, with more than 1.1 billion users, they run over 80,000 queries per second on Redshift. Yes, so you can tell it's a big service with hundreds of thousands of customers running exabytes of data on Redshift, and tens of billions of queries per week. And many of those queries are actually machine learning queries making predictions. So where are we going from here? Where will we put our investment in? Namely, 4 areas. From day one, we have been laser focused on our price performance, and we will continue to do so. Second area is zero-ETL. Simply put, we want to make that data ingestion into Redshift as seamless as possible for you. And the third area, we want to provide you that different possibility of working with Redshift data. Whether in SQL or Spark framework, it's all possible. And the last one of the most important things, we want to provide you that secure and reliable way working with your data. In terms of price performance, during last year at reInvent time, we did benchmark testing using the out-of-box features of Redshift. It turns out Redshift provides 6 times better price performance than alternatives on the market. And many of these are thanks to our performance capabilities, such as columnar storage, compilation caches, autonomics, and so on. We did another test, this time against BI queries, dashboard queries. So as you can see here, while the demand grows, Redshift can scale really well, while still keeping the cost low. 7 times better price performance than alternatives. So what are some of the features that give us this price performance? Serverless is one of them. So maybe a quick raise of hand. Any of you are using serverless? Nice, quite a few. So serverless was announced in 2022, and the idea behind is that we want to take away those burdens of, managing clusters and patching and maintenance away from you, so you can focus on getting insights out of your data. And many customers have adopted so far, and this is an area we will continue to improve and work on. Another feature here, data sharing, probably heard of that. The idea behind is that we want you to be able to share the data between different Redshift data warehouses, be it provision cluster or serverless cluster, without the need to copying the data and keeping the consistency of the data. So this is really useful when you want to dedicate a workload environment for specific departments, vendors, or user groups, or use cases. And many people have been using this together with serverless. Let's have a look. One of the examples. Peloton is a known sports equipment company, and as you can see here in the middle, they do have the Redshift cluster, which is provision cluster, acting like a producer, 24/7 ingestion. And they separate those consumer workloads, BI workloads, ad hoc analysis workload to different serverless clusters. In this way, they can actually share the data between different departments and vendors easily and achieve significant savings per year. And Alex from Smava, he's going to come up here and share more of those details later. So zero-ETL, it was announced at last year in Berlin. The idea behind it is that we've heard many customers saying that managing a data pipeline is time-consuming and error-prone. And we want to help you with that. So we want to help you to get data from your data lake easily using autocopy command, or from Kinesis using real-time streaming ingestion function, or from different operational data warehouses into Redshift in near real time for you to analyze all your data. So what our customers have been saying about zero-ETL? I know it's quite a busy slide here. So namely, 3 things. The first is speed. Many customers are saying that it used to take them months or weeks to managing that data pipeline. But now it's only hours or just days. And the second one is that managing that data pipeline no longer impacts the production system. Since that the replication happens on the storage layer. So it doesn't take much of the compute. And the third one is the real-time access to your data, so you don't need to ingest in a batch fashion anymore. There are a couple of operational databases. Now, you can get the data directly into Redshift. We've announced the zero-ETL integration between Aurora, MySQL, and Redshift. It's already GA'd. And a couple more things are on the way, such as PostgreSQL from Aurora, and 2 more databases like DynamoDB and Amazon RDS for MySQL. So really, you haven't tried it out. And someone will do a demo about it later as well. So we want to empower different personas in your organization to work with Redshift data. Whether data engineers, or business analysts, or data scientists, do you know you can already run your machine learning workloads actually using SQL command? Running those forecasts is totally possible in Redshift. And we're also very excited to have some new generative AI capabilities in Redshift. For instance, you can now bring your own large language models in Redshift. And another very cool feature is query editor with Amazon Q embedded function. So let's take a look how that works. As you can see here, now you don't need to be an SQL expert and to understand the complex databases and metadata in your organization to be able to get the data you want from your Redshift data warehouse. And all you need to do is write down what you would like to have in natural language, and Redshift query editor with Amazon Q embedded function will actually write those SQL syntax and queries for you and return you the results. How cool is that? Highly recommend to try it out. The last pillar we're going to focus on is security. So over the years, we announced many features in security out of the box, from authentication to access control to audit. We have row and column-based access control. We have fine-grained data control on nested data and late-binding views. We have dynamic data masking to protect your personal and PII data. And last year, we announced a new feature in identity center integration, which is allowing you to use your third-party identity provider to single sign-on once, and the authentication will be propagated to different services, including Redshift. So to have a really seamless sign-on experience. And this will be my last slide. It's all these innovations we're currently working on in those 4 pillars. As many of you know, we love to work back from customer needs. So let's welcome Alex from Smava and sharing with us their insights of using Amazon Redshift. Thank you, Alex.
Thanks, Lingli, and good morning, everyone. Thanks for joining us here in Berlin today. I'll be sharing today how we use Redshift and other accompanying AWS technologies to overcome some of our challenges while following our mission to make loans transparent, fair, and affordable. Let me start by introducing myself. I currently work as a principal data architect in Smava. I've been in data domain around 15 years, mostly as a data or solution architect, and 10 years of that was as consultant, and the last 5 years I've been in Smava. So far, I had the chance to work in 8 different countries, more than 10 sectors, around 30 projects with customers, and I also had the opportunity to work with different a variety of technologies among those years. What about smava? Smava is an online credit portal, and we are mainly specialized in consumer loans. smava was founded in 2007, and today we have more than 600 employees in 3 different locations. We are working with most of the major German banks. In 2016, we were able to provide first fully automated digital loan. And I know it can sound crazy nowadays, but in 2017, we were able to provide first negative interest loan in Germany. How do we change things? Let's start by looking at a traditional way of applying a loan. Let's say you need a loan. You would probably call your bank, try to get an appointment. If you can get it, then you would visit your bank, deal with tons of paperwork, and maybe after all, you could get a payout, and you wouldn't know that only in days or weeks. You might want to increase your chance to get a loan, or maybe a better or cheaper offer. So you could do that with multiple banks and increase your chance to get something which is better or whatever. And that will still take days or weeks to know if you're getting something. What could you do instead is you could visit our webpage, and we could get you offers from all possible banks just in seconds. And potentially you could complete the payout process just in minutes. How do we do that? Is the digital journey we provide. So if you're willing to use digital account check, if you get an offer using our AI-supported processes, which make sure you get the best and cheapest offer, if you close the contract by a video identification and electronic signature, you could complete the process just in minutes. How do we use data in smava? Smava strongly believes in data-driven decisions in order to become the market leader. So every day, we are taking decisions, hundreds of decisions that are data-driven. We use data intensively to measure how feature changes affect the customer journey, and we keep improving our applications and solutions with those measurements, and as a result, we have happier customers, happier banks, stakeholders, and also engineers. Besides, in smava, we have many AI-supported processes and applications that help continuous improvements across the organization. And talking about all those, of course, we have data in the core. Let's look at our data platform and team. So in our data platform, we serve approximately 60K queries per day. The data volume is about double-digit terabytes with a steady increase of 53% year-over-year growth. When we look at our team, we have around 25 people with different roles, such as analysts, analytics engineers, data engineers, and data scientists. If we talk about our customers, of course, it's hard to tell nowadays that there is a team or a department that's not producing data or consuming data. Of course, that's making almost everyone in our organization our customers. Slowly shifting to the data architecture. So we are using very well-known AWS modern data architecture patterns. In the middle, we have a data lake layer. Around, we have purpose-built data stores. And the data movement can be inside to out, outside to inside, or around the perimeter. Let's get more familiar with our data architecture in high level. On the left-hand side, you can see various data sources, which we first ingest into S3. That could be different types of internal or external data event streams, or different types of internal and external data stores. Our data warehouse is on Redshift, and under the hood, we have Data Vault. After ingesting the data into Redshift, we are using dbt for transformations. For orchestrations and also integrations, we use Dexter. When it comes to dashboarding and BI, we are using Tableau. And on the other hand, for ad hoc and discovery purposes, we are using Athena and Hex. All right, let's have a look how things evolved in our data platform over years. At the beginning, as usual, we had a single huge Redshift cluster, which served for different use cases and different group of customers and etc. And we had a variety of sources and consumers, which you can see in this slide. Isolating the workload, dealing with security, stability, etc. was pretty complicated. Scaling was not flexible and easy, and also, cost-wise, could easily become inefficient. We had a lot of consumers fighting for the same resources, and of course, that was causing an issue. As a result, we started to get complaints mostly around performance. Of course, we tried different ways of scaling, optimizing the workload management, and that, of course, helped us, but only up to a certain level, a certain extent. And we knew we needed another solution. As an interim solution, we created another Redshift cluster and split our workloads according to different use cases or group of customers, etc. That helped us with some aspects, but also brought new challenges, such as we needed to copy data via S3. That created a new layer, extra maintenance, and also latency. That helped us for a while. Over time, we started to get complaints and requirements from different perspectives and different group of people. We listened to our customers and also ourselves and collected all those requirements and challenges in those 5 pillars, which are performance, scalability, cost efficiency, productivity, observability, and governance. I need to tell here that we also had major organizational changes which drove us to rethink about or modernize many of our processes, architecture, and tooling in our platform. At that moment, we were very lucky to have Amazon releasing data sharing and serverless, which became big enablers for us in order to implement the ideas or the solutions we had in mind. Without those, which would not be possible. Let's have a look how we use data sharing and serverless to modernize our architecture. So when Amazon released data sharing feature, we were very happy to adopt it in our data platform and split our computation into multiple clusters. That was a game changer for us. That allowed us to have instant access to the data produced from different clusters, and at the same time being able to isolate and optimize those workloads according to the different use cases or purposes. Although we still had some new challenges, such as resuming and pausing those on-demand clusters were taking time, and also that required a trigger. In very rare cases, we also had problems with allocating resources for those on-demand clusters. And when it comes to scaling, it was not that easy, and it required time again. Next, we had Redshift serverless being generally available. Again, we were very excited and happy to adopt it in our data platform. The first step, what we did was we moved the clusters or the workload where we did our developments or batch loads, such as testings and production workloads, which was a very easy kill for us, but coming with a big return in some aspects like performance, cost efficiency, scalability, stability, etc. After those changes we implemented, our data architecture looks like that. So in summary, we have a combination of still reserved instances, on-demand instances for different purposes, and also serverless warehouses. And also, we see data sharing in action here, which is allowing to share data instantly among those clusters and warehouses. Besides data sharing and serverless, of course, we are using many built-in features that Redshift is bringing to us that Lingli was mentioning earlier, such as autonomics, automated workload management, data lake analytics, federated queries, etc. Right, let's have a look at the business impact we had. After the changes we implemented, we had happy customers, and also we started to get messages completely from the opposite direction, such as, is everything magically too fast, or do we actually have a problem? Or people questioning, hey, we don't have any alert or issues for a long time. Are we maybe missing something and we have a bigger problem, or is it really the case? Or good feedback like, it's very good to have access to data at one place. So here I need to tell that it was, of course, not data sharing or serverless solving those issues themselves, but those were our big enablers to implement the ideas, modernize the architecture, change the processes and toolings, which allowed us to achieve these goals and results. Let's have a look at a use case that we make possible in our data architecture. It's crucial for our organization to make fast, precise, and data-driven decisions, and also take actions accordingly. Earlier, I told that we are bringing a customer journey that could be completed in minutes. But not everybody is following that journey. Not everybody wants to follow a fully digital journey. Some of the people just pause their process and come later. Some of them don't even come back. If we would wait for real conversions, it could easily take for us days or maybe weeks to understand how do we perform. If we would, what we do, we store a big variety of data points from the journey of the millions of customers we have. We learn from those. We constantly train our machine learning models. And using those, we try to estimate our sales volumes, which, in another saying, is we are trying to understand how likely are leads to convert into sales. And thanks to our machine learning models, we are able to have an idea just in scale of hours instead of days or weeks now. In that slide, we see how we maximize the ROI for some of the campaigns we run. Amazon Redshift, with data sharing and different types of clusters and warehouses we have, is fully in action here. We first ingest data in our data platform in near real time. We create centralized and decentralized products on top of that for different purposes. And we share this data using data sharing among those different teams instantly. Using the reports and estimations, we are able to take fast and precise decisions. And on the other hand, we constantly optimize the ads being shown to people by feeding the same data to the APIs. That's helping us to maximize the ROI constantly. Let's look at the summary of the achievements we had. We increased the performance up to 5 times while pushing down the cost 50%. Our data platform is much more scalable and flexible. We significantly decreased the engineering cost per task. We are much more resilient, so whenever we have an issue, it's fast to recover, and it's hard to turn into an incident now in the layers that we addressed. We decreased the maintenance cost significantly also. When it comes to the time to market, we dramatically decreased that from hours or days into minutes. What is in the horizon for us? Looking at the results, we are very happy with servers, and we definitely want to invest more on Redshift serverless and move more. When it comes to data sharing, we know that now it supports writes, and we want to get more benefits from that. And about zero-ETL, we are very excited to have it generally available in our region now, which we will definitely adopt in the near future. We want to minimize the maintenance costs, keep on that path, And we want to elevate decentralization and data democratization in our data platform. When it comes to generative AI, we already have many initiatives going on, and we want to explore more on that. And knowing that we have a good foundation, data foundation, I'm pretty confident on that. Saying that, I want to thank you all, and I want to hand over to Saman for the demo.
Thank you very much, Alex. Hello, everyone. My name is Saman Irfan, and I work as a specialist solutions architect at Amazon Web Services in the analytics team. And today I'm here to demonstrate the end-to-end analytics with Amazon Redshift using Amazon Redshift differentiated features such as Amazon Aurora zero-ETL integration with Amazon Redshift, Amazon Redshift data sharing, Amazon Q Generative SQL capability in the Redshift Query Editor v2, and in the end, visualization in Amazon QuickSight. So before starting the demo, let us briefly discuss the business use case. So let's imagine we have an example corporation, and they have the data coming in from the wide variety of sources on which they want to run analytics and business intelligence to address different use cases, such as fraud detection and inventory planning. They also have multiple workloads, such as ETL, BI, and machine learning workloads with the different SLA requirements. Moreover, these use cases cannot bear the lag of ETL bad jobs, and the data needs to be available in near real time. So how can AWS help them? So to solve these challenges, we propose Example Corporation to set up a zero-ETL integration between Amazon Aurora and Amazon Redshift, as in their case, the data resides in an Amazon Aurora MySQL database. With this integration, as the data is written into the operational and transactional data store, it is made available in Amazon Redshift in near real time for advanced analytics. Now, on the Redshift side, we propose to have multiple Redshift warehouses for the different use cases, such as an ETL Redshift warehouse for processing the ETL workload, a BI Redshift warehouse for the business intelligence use case, and an ML Redshift warehouse for the machine learning workload. These Redshift warehouses can be either provisioned or serverless based on the workload requirement, and the data is shared between them using Amazon Redshift data sharing. In the end, they can use Amazon Redshift Query Editor v2 for ad hoc analytics, and Amazon QuickSight, which is our fast, cloud-powered business intelligence service for self-service reporting or BI dashboarding. So let's see this in action. So in the first part, we will showcase how easily a zero-ETL integration can be configured between Amazon Aurora MySQL and Amazon Redshift. With this solution, you can configure an integration from source to target. You do not need to create or maintain any ETL pipelines, as we take care of ETL for you. So in our demo, the data is stored across 8 tables in Amazon Aurora MySQL, and we need this data to be available in Amazon Redshift in near real time to perform advanced analytics. Now let's start this demo by reviewing the source first, which is our Amazon Aurora MySQL database. For this, we go to the RDS console, and on the RDS console, you all can see that we have this Amazon Aurora MySQL database already created. Now we review the target, which is Amazon Redshift. So we go to the Amazon Redshift console, and here we can review that we have created 2 Redshift warehouses, serverless, one for processing ETL workload and one for processing business intelligence workload. Now, to create the zero-ETL integration, we go to the source, and on the left pane, click on the Create Zero-ETL Integration, and in the next step, we click on Create Zero-ETL Integration. In the first step, we provide the integration name. So here we are providing the integration name. In the second step, we need to select the source, which is our Amazon Aurora MySQL database. So we click on the simply Browse RDS database, and here we select our source database. You can also specify the data filtering option to include or exclude the tables from this integration. In the third step, we select the target, which is our Amazon Redshift database. The Amazon Redshift data warehouse can be in the same AWS account or in the different AWS account as well. So simply click on the Browse Redshift data warehouse, and here we can select the ETL Redshift namespace, which we have configured for processing the ETL workload. In the fourth step, we can specify the tags as well as encryption setting. The zero-ETL integration is encrypted by default, but in case you need to specify your own encryption keys, so you can specify that. We review all the setting and click on Create Zero-ETL Integration. Now, this creation takes around 15 to 20 minutes. So let's say we are back after 15 to 20 minutes, and now the status is in an active state. The last step to make this integration works is that we need to create a database in the target from that integration. So we go to the target, which is our Amazon Redshift, and we connect to our ETL Redshift warehouse in the query editor v2. So in the ETL Redshift warehouse, we have to create a database from that integration. So we get the integration ID from svb_integration system table, and once we have this integration ID, we simply use simple create database SQL command to create a database from this integration. Now, once we have this database created, we go to our ETL Redshift warehouse and simply refresh it. And here you can see that we have this database created currently with the public schema and no tables. Now, to showcase the replication, real-time replication from the source to the target, we will use an EC2 instance in this demo to load some data into our Aurora MySQL database and see the real-time data movement from the source to the target. So we connect to an EC2 instance using Session Manager, and in this we will use AWS CLI commands to connect to our source. So here we will be connecting to our source now, which is our Amazon Aurora MySQL database. And we will create the database and 8 set of tables that I shown you earlier. So here we are creating the database, and then we have created all the 8 set of tables. Now we will start loading the data in these tables, and once we have the data loading operation started, we go to the target and verify the data movement in real time. So we refresh this Aurora_zero-ETL database, and now you can see we have a schema, DemoDB, with all the 8 tables replicate available in near real time, and we select the count from these tables. And you can see that we have 5 tables already loaded, and 3 tables are still in the loading process. We go to the source again and check our loading process. It's still going on. Okay, so we go back again to the target, verify the count, and now we have 7 tables loaded, and 1 table is still in the loading process. And now we check that the data loading operation has been completed, and now we can see that all the tables are replicated to Amazon Redshift in near real time. We can also check the data from any of the tables. So let's review a table such as line item, and we can also verify the data that it's loaded appropriately and accurately. So with this demo, you have seen that how we have loaded the data from operational and transactional data store to Amazon Redshift in near real time. Now, once the data is available in the ETL Redshift warehouse, the data can be shared with the multiple Redshift warehouses, which are configured based on the workload, price, and performance requirement. These Redshift warehouses can be either provisioned or serverless. So in our demo, we will share the data from the ETL Redshift warehouse to the BI Redshift warehouse, which is configured for the business intelligence use case, and we will perform some BI workload on it. Now, to create the data share from ETL Redshift Warehouse to the BI Redshift Warehouse, we go to the Amazon Redshift console. And I have shown you earlier that we already have 2 Redshift warehouses, ETL and BI. To create the data share, we will go to the ETL Redshift namespace. So in the next step, we open the ETL Redshift namespace. And under the data share option, simply click on the data share tab. And we connect to the ETL Redshift warehouse. And under the data share created in my namespace, we will start creating the data share. So during the creation of the data share, we have to specify the data share name. We have to select the database that we want to share. So in our case, it's Aurora_0-ETL. And then we can also add the objects in that data share. So we select the schema. We select the tables and views and either user-defined functions that you want to share. You can specify specific object from the schema. And here, we are selecting all the objects, all the 8 tables we want to share from the ETL to the BI. Now, in the consumer option, you can either share to the Redshift directly, or you can share to the data catalog and use lake formation for the centralizing the permission management. In our demo, we publish it to the Redshift and the BI Redshift namespace we have selected. And we clicked on Create Data Share. Now, once the data share is created, it's visible under Data Share created in my namespace in the ETL Redshift warehouse. In the last step, we have to create a database from this data share. So we go to the BI Redshift warehouse, and in the BI Redshift namespace, under the data share tab, we first connect to our BI Redshift warehouse. So once we are connected, we will be able to see our data share available here under data share from other namespace and AWS accounts. So we create the database from this data share so that we can, in the BI Redshift warehouse, we can query it later on. And here we have created the database from this data share. Now, to query the data, we again connect to our Redshift query editor. And in the Redshift query editor, we connect to the serverless Redshift warehouse. And once we are connected to the BI Redshift warehouse, we can see an external database, TPC, available, and with the DemoDB schema and all the 8 tables available, which is basically we shared from the ETL to the BI namespace. And here we can select the data from any of the tables, so from the customer table, and also run the business intelligence workload on it. So we are running a query such as, tell me the top 10 countries with the highest priority order. And you can see that all the data is coming from that external database schema and tables. So once we have executed the query, you will be able to see the result set. So in this part of the demo, you have seen that how simply you can share the data from between different Redshift warehouses and enable different use cases such as workload isolation, cross-group collaboration, deliver data as a service, and so on. Now, once the data is available in the BI Redshift warehouse, you can interact with Amazon Q, Generative SQL capability in the Amazon Redshift Query Editor v2, which is a coding assistant that generates the SQL statements for you based on your prompts in the natural language and database schema. This coding assistant is available while you're authoring a notebook in the Query Editor v2. So let's see this in action. So to use the Generative SQL capability in the Query Editor, you have to enable it first. So in the Setting tabs, you can enable the Generative SQL. And one very important point to note, this capability is currently in the public preview and available in 2 AWS regions, which is Oregon and North Virginia. So you can simply open the notebook, and here we just verify that we are connected to the BI Redshift warehouse and start using the Generative SQL capability. So the first prompt that I gave the Generative SQL is that tell me the list of suppliers and parts where the available quantity is greater than 1,000. So we give this the prompt, and it will generate a SQL code for us. Very important to note that you need to have some basic understanding of the SQL just to verify that the query it returned is accurate initially, because it needs some time to train, because it's behind the scenes, it's using the large language model on Amazon Bedrock. So we check the query, we see that, okay, it's using the right table, the filter is applied, and here we can use this query to generate the result set. The second query that we ask is that how many orders were sent by supplier and provide the supplier name. And here it generates the query for us, and you can see that all the data is coming from the external tables, TPC, demo, DB, and all the tables with the accurate filters, and we simply add it to the notebook and run the query, and it generates the result set for us. So this is where you can see that how it can basically improve your query writing capability and accelerate your work. In the third, we ask, OK, tell me the list of suppliers by the order count. We simply add it to the notebook and run this query to execute the result. The last query, and here again, you can see that all the tables are coming from the external schema, and it has generated the query for us. The last query which I asked is that, what is the total orders with the ship mode equal to rail? And here it has generated the wrong query for me, because the ship mode column does not exist in the order table, but the line item table. So I basically train this and tell that, OK, tell me the total orders with ship mode equal to rail, and the ship mode column is in the line item table. And now it generates the accurate query for me, and I have executed it to get the results. Now, in the end, we can use the Amazon QuickSight for the data visualization, which is a fast, cloud-powered business intelligence service that delivers insights to everyone in your organization, and it is a fully managed solution. So to use Amazon QuickSight, you can go to in the search bar, you can search for the QuickSight. Very important thing to note, we are not going deep dive into the QuickSight here. We have a lot of generative BI capabilities in the QuickSight as well, which you can, if you want to learn, you can go to the AWS World section in the Summit, and there's a demo booth with a generative business intelligence, so you can try it out. So here we have already created the analysis over the data that is in Amazon Redshift, and you can simply publish this analysis to a dashboard, and you can, once it's published to the dashboard, you can review this analysis, you can review the dashboard, and once you're happy, it gives you the insights, you can share this with the rest of your organization. So if you want to learn more, as mentioned, you can go to the AWS World section and go to the Generative Business Intelligence demo booth. I know we have shared a lot of information with you all, but if you want to learn more, we have compiled a set of resources for you, which you can get by scanning this QR code. One very important resource is a blog post which we have co-written together with our customer from Smava, and in which they explain their journey on how they built a modern data platform on AWS. So do check that out. And if you have any questions, Lingley, Alex, and myself will be staying outside the breakout room for some period of time, so don't hesitate to reach out to us. Thank you very much.